Good morning, good afternoon, or even good evening, depending on where you are in this world. And welcome to the AI Catalyst for Global Health course. And I am your host today. My name is Cooper Chan for this very first section about Introduction to AI and Healthcare. I'm glad that you're here, but too bad that we are not meeting in person. So that's why I cannot really see your facial expression or either good or bad. I'm doing good job or not, I do not know. So in order to mimic what we can see each other in real person, let's go over some logistics, shall we? So throughout the whole hour of this class, you will see this kind of emoji. And then at the same time, not only this emoji, but you will hear something like this. And whenever it happens, that means I'm not only needing your attention, I need your participation as well. So let's try this. Whenever you need to pay attention and participate. And the very first question that I want to ask you is, where are you? Where are you from? Because the organizer told me that we have a lot of people already registered for this class. I really want to see where you're from. So in order to really interact, open up your chat window in the Zoom. And in fact, this is the only way I can see you right now. Until the end of this section, I'm going to open everything up and then we can even chat more in the Q&A. But for now, open your chat window, not Q&A window, chat window. Type in your answer in the chat window so that I know where you are from. In the meantime, while I'm waiting for your response, let me give you a little bit of my background. My name is Cooper Chen. I am the CEO and co-founder of Pistol Decision. Pistol means trust or belief is a Greek word because even though we are an AI or technology company, we know that just having a cool technology will not make you to become successful. What really makes you be successful is whether your user can trust you or not. So that's why we picked this name. And on the other hand, not only my like a day job as a CEO of Pistol Decision, I am also the chair of the BI and AI committee at Linux Foundation and was also appointed as a senior fellow in both Johns Hopkins University and University of Maryland. So that is my professional life. And in my personal life, I live in the Washington, D.C. area. I see there are a lot of people. Some people are actually from Maryland, California. I am glad that you can join because now, like West Coast is only 5 something a.m. So I appreciate you joining this call. But for me, as I said, I live in Washington, D.C. area in the East Coast. So not too far away, maybe 2, 3 hours driving from my home, I can go to Hershey Park. In case you don't know, Hershey Park is basically Disney World with a lot of chocolate. And but when I say Disney World, that means they have rides and like a long line because some of the rides are very popular as well. And before the pandemic, when my kids were young, we used to go there in the long weekend and just to chill and then play something. And because there is a long line, when we line up, my son suddenly asked me a question out of the blue. Hey, Dad, what are you doing at work? At work, I do AI. So I collect all the data from different sources and try to get rid of those no value before I do the feature engineering. This kind of data, I will feed it into the multi-layer neural network. And in order to reduce the error rate, I usually will approach by using the approach like gradient descent to reduce the error. Hold on. You don't think I really explain my son the AI work that I do every day, right? Of course not. Not because he's only a 7 years old boy. He may not have that like a mental capacity to understand what I'm talking about. But I really don't want him to think my dad is crazy. I asked him a very simple question of what he is doing at work, and he answered me, seems like English, but I cannot really understand anything of what he said, and I better not to ask him anything anymore. Of course, I did not explain to my son like that. In fact, I borrowed the very famous AI explanation from Alan Turing back in 1950s. You know, I do AI at work. And think about AI as like you have a computer system, you teach a computer system so that this computer system, when it responds, you cannot tell whether it's from a human or from a machine. That is an AI. And he said, oh, that means I can use AI to do my homework, and my teacher cannot tell whether it's me or the computer doing the homework. Is that the AI? Well, teacher can't tell. Is that equals to AI? Not really. Do you remember how we teach your younger sister to recognize some objects? We'll bring up an apple, and then we'll keep on saying that, you see this round and red thing you can eat and smell good. This is an apple. And then we bring up a pen. Let's say this blue pointy thing, you can use it to write. That's a pen. We keep on showing her different examples of apple and pen. Sometimes we hope that she will recognize and associate this red round smell good. You can eat this thing. This is an apple, and this is a pen. And you know what? In AI, this is called supervised learning. We are trying to associate supervised learning. We associate the feature, which in this case can be red, can be round, can be blue, to a label, in this case, can be an apple or can be a pen. And that is supervised learning in AI. Uh, if you have a kid like me, you will notice that sometimes it's very hard to keep it organized. In fact, the second law of thermodynamics also tells this. Unless you really put your effort or energy to keep things organized, things will just getting messier and messier. And for kids' playground, this will be something like that. So in my house, it's my mother-in-law holding the responsibility to help my kids to keep this playground tidy. And I still remember a few years back, she flew back to Hong Kong to take her vacation or break. And after a few weeks, this whole playground getting messier like that. And then the weekend, right before my mother-in-law fly back home, my wife just tell my kids, I don't care how you are going to do. You need to clean up the playground before grandmom comes back home. Within a few hours, no special instruction. Guess what happened? They put the soft, fluffy thing in one box, one area, and they called it stuffed animals. And then they put all the like a small little toy with a wheel with four wheels. They group them together and they called it like Hot Wheels. And they also put all the boxy thing together. You can stack everything and then make a model or house. They put that in another box and they called it Lego. And without any special instruction, they put everything together unsupervised. And this, you know what? It's also another area in AI called unsupervised learning. In this case, for feature, we do not really give any special instruction or feature to the computer, but the computer itself, based on the algorithm, it will sort out all kinds of relationship between all the data points. So that's unsupervised learning. When you teach a kid, sometimes it's not only showing the kids an example and trying to give it as a supervisor learning, or just give no instruction and assume the kids will just follow, which is unsupervised learning. Sometimes when the kids do good, you need to award the kids' behavior. Or on the other hand, if the kids do bad, you also need to discipline to correct the bad behavior. In this case, this is called reinforcement. And for AI, we also have something called reinforcement learning. The goal here is we will either increase or decrease a point of the system depending on whether the system does the good thing or the bad thing. Now it's another question time. So, what do you think is the most commonly asked question by the kid? Let me see. Uh, Keep your answer coming so that I know that you are not only paying attention, but also participate, okay? So let me know in your mind, what is the most commonly asked question for the kids? Okay, why? Okay, good, perfect. I think, like for me, why is the most commonly asked question, at least in my case. But for the second and the third place, I would say is like, are you a boy or girl? Or how old are you? I still remember it's a little bit embarrassing when my kids, they were toddler, they start learning and trying to interact with the world. And then they keep asking this kind of question. How old are you? Are you a boy or girl? But, you know, these two questions also form a very foundational like question for AI as well. When you are asking people about what's your age, how old are you, you are asking people to answer you in a number. So this is regression in AI. When we are trying to get an answer as a number, that's the regression. But then on the other hand, if you are asking someone and you expect certain preset category, let's say a boy or girl, or it's a Monday, Tuesday, Friday, which month, you actually have a category for that. That is classification. That is also another way for people to really understand of what happened in this world by number or by category. So when we break down how a kids are really thinking, you can actually see that a kids will try to observe the world, what happened, and after the observation, this little kid, this little mind will form certain rules in his or her mind. And this rule, when applied, it will try to produce or predict certain result. And this result sometimes is correct and sometimes is not. But whether it's correct or not will help the kids to determine whether he or she should change the rule in the future to mix how the kid will think about this in this whole flow. But if you bring this how a kid learn to reality. This actually very similar to how a developer building the code in the old way. So a developer would observe the world. Maybe this is being done by BA, business analysts, to provide certain rules for the developers. And then the developer will then come in and then try to code the rule in the program. And the program will produce the result, and the result will be reviewed by the developer. If it is not true, it's not good, that means you have a bug that you need to correct your rule. So this will happen again and again to make the program being better and better. But the way that it is doing, I call it, you are just teaching a man. It's not teaching a man to fish. You just give a man a fish. But when you give man a fish, you will just feed him for a day. However, you heard this old saying, if you teach a man to fish, you will help him to fish for a lifetime. When we apply this in computer, this could be also true. If we give a computer a code, you will help it to solve one situation. However, if you teach a computer how to code, you will help the computer to solve a collection of situations. So if we are talking about AI, remember in the very beginning, we are talking about AI. Basically, it's something that demonstrate the intelligence or mimic the intelligence of a human. That's AI. And in fact, the old way of AI is rule-based. We observe a lot of different rules and then produce an expert system. Hopefully, through this expert system, the AI or the system will exhibit the intelligence of a human. That is AI, but that's not the best AI, because you are just give a man a fish in this case. What if you can teach a man to fish? Machine learning. This is what really differentiates from the traditional AI or the broad AI term versus machine learning, which you tell the machine how to fish. And then the machine will figure out the pattern so that when it gets more and more problem coming in, you don't need to tell the machine because it knows how to fish in that case. And if we apply this to a scenario like that, developer would then pull himself out of the picture. Instead, it will create certain algorithm, and this algorithm will collect the data from the real world and then start training not rules, but the model. So the model will then try to predict the unseen based on the unseen input for the result. And once the result is ready, then we can perform certain testing, very similar to how a kid or the traditional developer learns. If there is an error to make this result not correct, this will then become trained again. It will become the machine's experience to retrain it again. So when we use this, we can now see two very unique cycles in this loop. One is training. We use the data, we use some known data with feature and the label to produce the model. And then at the same time, the model will then be used in the real unseen data to do the inference, to predict what's the result. So that's basically is how we change from the old AI way, rule-based or expert system, to machine learning. Now, next question. This is a tricky one because I want you to name which one is the second largest restaurant in the world. Please type in. Please type in your answer there. And let me see how many of you can get the answer correct. Not the largest, but the second largest. Okay. MCD, McDonald, Olive Garden, Burger King. Okay, good. I think most of you are not tricked by this question. Correct answer is actually McDonald's. I was surprised. I thought McDonald's is the #1 restaurant in the world, but I was wrong. It's overtaken by another Chinese, like a, what is that? Like a ice cream dessert tea place in the world. It's overtaken McDonald's. So McDonald's now this year is actually only the second largest restaurant in the world. And maybe you like it, but kids for sure they like McDonald's. Not only because of the burger or fries. They like it sometimes is because of the toy of the Happy Meal. And I still remember when my kids they were young, there was a toy called Guess Who. And this is what that looks like. So basically, it has a set of, actually, two sets of 16 cards. And each little tiny card, they have different characters. Some are like playing piano, violin, snorkeling, whatever. Okay. So the goal of this game is you play with your opponent and you pull one card, put it on the slot right here, put it on the slot right here, and then you let your opponent to guess, take turn to guess it. And when I observe my kids to play this game, I feel like, what are you guys doing? Because they basically look through their own set of cards and try to pick it one by one, and maximum 16 times. Of course, you can guess what's the card, right? But then something happened. After a few days, I find out that they changed their strategy. Instead of getting all these cards sequentially trying to guess, they will ask questions like, does your card having some purple on the card, on this character? Or they'll ask, does the character having any hair accessories? Or does the character holding anything? Something like that, to basically narrow down so that they will eliminate a part of the card. Instead of guess 16 times, now they may guess like 2 or 3 times. They can guess the correct card of the opponent. And this is actually one of the way of machine learning. I call it shallow learning. It's called decision tree. We ask the question and we break down the question so that we can get the correct answer faster. That is the decision tree algorithm that we use in AI. And in fact, if we look at this, for the whole AI and machine learning, we are missing out one more thing, which is why today we talk a lot about AI. It's actually because of deep learning. Deep learning is within machine learning, but it has one more level. Remember that in the machine learning, we will also need to provide certain feature so that the machine can, or the algorithm can then use the data to understand the pattern in the data. So we as a human or expert or data expert, subject matter expert, we still need to provide that kind of knowledge for the algorithm to train the model. In deep learning, it's actually, we don't need that because deep learning uses neural network. And neural network, by looking at a lot of different data as a sample, the network would start learning what kind of feature is being embedded in this model. And you may remember I said Alan Turing, right? He proposed the idea of AI back in 1950s. But why only now in the past maybe 10 years AI is so so hot right now? There is a reason. The reason not only because many people think about AI, machine learning, and even deep learning, they think about this. They think about algorithm, which is important because without the improvement or the enhancement for the algorithm, we cannot move from like the rule-based expert system to machine learning so that it can find the pattern to deep learning that it can also understand the feature without telling it. But there are two more different things, which is also very important to make why AI is so hot today. It's data and also hardware. Let's think about all this cool algorithm, deep learning, without a lot of data to support. You cannot run the deep neural network because it requires the data to form the pattern. And if you have these two, and without hardware, you still cannot do much because deep learning, for example, is a very computational intensive process. So you need a lot of computational power in order to make the deep neural network works and efficient. So with that being said, what happened in the past like 70 years? In 1950s, for sure, we don't have that much of the data. We don't have that advanced of the hardware to support the calculation or the computation. However, in the past 20 years, as phone become very popular, as people are getting involved in different social platform or the hospital or even different organization, email, all these kind of digital like assets become another pillar. Not to mention the GPU also is another way to make the perfect storm for boosting AI from just a rule base to deep learning. And now almost everyone are using AI every day. Then another question you may ask is, wow, I have a lot of data right now and I have all kind of hardware. Then let me keep training so that the model is so good that not only 70% accuracy, but 100% accuracy. Let's do that. Let me pause you here. Because if you think about in reality, okay, so we have different data sets. Let's say this is some value we can plot by collecting all the data here, okay? So we are trying to plot this, and of course, the goal, the perfect scenario is I can form a model that will match as much as possible. However, if you train too much, if you're overdoing that, you may actually form a model connecting all the dot that you have already known as the input data to train the model so that you get the 100% accuracy when you use the training data. But this is the problem. And this problem is overfitting. You overfit the model so that it's basically memorized the data point that you use for the training. So it's just like when my daughter, when she first learned math, I taught her 1 plus 2 equals 3. And I asked, do you understand? Do you know how to the addition? She said, yes, I know that, Dad. 1 plus 2 equals 3. I said, good. Now, let me ask you, what's 2 plus 1? And then she said, I don't know. You did not tell me. You did not teach me what is 2 plus 1. So that's memorizing. That's overfitting in AI. You train the model too well to fit into the training set of the data, but you forgot about how to generalize the model to apply to the real world. Now, another way is also not good. Some people will say, okay, I just randomly train something that will give me this model. This is another extreme. It's called underfitting. So basically, underfitting is like you train, yes, but not good enough so that the model cannot really capture the underlying pattern of the data set. That's also not very good. So the optimal way is to train something that is general enough, but not memorize the data points. That's the goal of how to use AI to the optimal way. Now, let me give you like a practical question. Okay, so let's say I want to come up with an AI program to calculate the circumference of a circle like this. Okay, how can I build up an AI model or AI program to calculate the circumference of this circle? Okay, so in order to do that, remember, in AI, we need sample, right? So we give a lot of different size of the circle. Maybe I will give like one big circle like this also. So by doing this, by keep on measuring the radius and also the circumference, the radius and the circumference, I will come up with this table, okay? For this table, I have all the sample of the measurement. After I got the measurement, Gilbert, you told me, right? I can forward to maybe a deep neural network, and then the deep neural network can find the pattern, to find what really can do in order to calculate the circumference of a circle. But hold on, Cupid. Are you over-engineer? I can easily calculate the circumference by 2 times the radius, which is the diameter, times pi. That's the formula. Why do I need to go through measuring all this kind of like a circle, radius, and then the circumference and come up with something that is so complicated? You are correct. AI is not, or at least in machine learning, finding the pattern or deep learning, would not always be the solution. Because sometimes, especially if you have already know for sure what really is the relationship for this kind of data, the input data, and then you know definitely how to calculate. Example is this. You do not need to use AI always. It really depends on what kind of problem you are trying to solve. Then you apply AI, it will become effective. Otherwise, you are basically engineer something that can be resolved in one line of code. That's not good. Now, next question. So, what are the 5 senses that we have? Okay, as a human, what are the 5 senses that we have? I hope you can at least give some. Oh, wow, very great. Sight, smell, touch, sound. Okay, good, perfect. Some of them got all 5. Some of them got like maybe 1 or 3. They're all good. So let's try to think about this. So it's vision, okay, smell, taste, hearing, and touch, right? 5 senses. But if you use AI correctly, I would say AI can actually help you to do 6 senses. Really, the 6th sense is, oh, by the way, I hope you guys know about this movie. This is actually one of my favorite movie back in, I think, 1999. It's a famous movie because it talks about something that I have never thought about. So besides all those 5 senses, someone may have the 6 senses. That means they can see something we cannot see. They can hear something we cannot hear. So I would say if you use AI the right way, you can actually achieve sixth sense in this manner. So I would say sixth sense, right? Okay, vision. Okay, let's put vision here. So, we can really see something in the daylight, in all the regular environment. But what about something that is really hidden that you may not be able to see? Can AI help? And how AI help? Now, this is the next question. So this time, please pay attention to your screen because I am going to show you a picture, and then let's see who can guess what is this picture the fastest. Okay, so now let's start. I'm going to show you a picture and tell me if you know what is this. Okay, now it's coming. Let's see who can get this the soonest. Okay. Okay. Now. Wow. Most of you actually get it correct. This is a tiger. You're right. This is a tiger. But what you did not notice is you have just performed CNN, convolutional neural network. When I say AI can see, AI cannot see like what we see. We need to teach the AI to see. And in order to effectively get the AI to see, we actually break down the whole picture in smaller patch and show the AI one by one, just like what I showed you on the screen for the full picture. I'm not going to show you everything, but I show you piece by piece, sliding this piece by piece. At some point, you get enough information so that you can guess that's the tiger. And when we build this convolutional CNN, convolutional neural network, we are actually building multiple layers in the deep neural network. And different layers will keep on advancing the complexity of the context. In the first layer, it may only understand the straight line, the curve, the very primitive shape of the picture. And then as we feed more and more data in the next layer or layers, then the lines may become an eye or a ear or mouth. Then the next layer would become a face, and then finally the full picture. And this is how the CNN in AI look at the world when we teach the right way how the AI should see. And back in healthcare, not only we can teach a machine how to recognize a tiger, but when we show now some cancer cells image versus some good image without cancer cell, it's just like showing my daughter like a red round apple or blue pointy pants. Like it was for my daughter to recognize objects. Now is for the computer to recognize whether an image having cancer cell or not. So this kind of supervised learning is also very helpful in healthcare. So not only eyes, we also have ears and mouth. For the ears and mouth, what really is the difference between an eyesight or for vision versus ear and mouth? Usually we use ear and mouth to talk and communicate language. And the major difference between a language and also a picture is in sequence. So let me ask you, when is my next trip to Boston? You may say, huh? I don't know. But if I ask you, do I have a son? Then you will know that, yes, you have a son. Why? Because in the previous, let's say, 30, 45 minutes, I have already mentioned that you understand, you memorize that in that context, you know that I have a son. So language is a sequence kind of data. You need certain context, you need to remember certain things in order to understand and make the prediction for the question. So in this case, we use RNN, recurrent neural network, to understand the language, to understand the data in sequence. In fact, not only in daily life using the language, if you think about this, in healthcare, there are a lot of sequential data. And one of them is the longitudinal EHR data. If we put them together, in fact, some of the researcher has already proved it. They can use longitudinal the EHR data and apply RNN to predict the heart failure. That's something that is very proven. And I hope you can also understand that it's not only like knowing the AI, but how is it going to apply AI to real life? So now, besides all this, what else we can do after the facial? We also have, I'm sorry, my bad hand drawing, but it's the hand and also the body. AI can also be our body. How? Remember the reinforcement learning here? So we usually apply reinforcement learning in robotics because robots has different motors and sensor. So when a robot trips, all the data being recorded for how the sensor sense and how the motor moves will be logged. And then based on this data, AI can then be trained. I should not use this kind of force and angle to move, otherwise the robot will fall. So as time goes, when we give it the point, when the robot can keep on walking or even jumping without falling, then the AI knows what is the right angle and force that can be applied and should be applied so that the robot can keep jumping or walking. On the other hand, if the robot falls, the AI can also reduce the point. So that means the AI would teach the robot how to move as a body. And not only like a for fun robotics, but what if we apply robotics in surgery, which is happening? If we use robotic surgery and include also AI there, that will increase a lot of accuracy. So besides this whole thing, this is us, right? All the vision, ear, hearing, or the body is us. What if AI can expand beyond that and become someone as an assistant to us? And what happened? AI can also do that. And let's imagine something like if I keep on, if my closet is very messy, right? I want an assistant, maybe my wife and maybe my kids, to really get all those organized. By applying AI to the right way, they can also sort that out by pants and outdoor clothing automatically. This kind of, let's say, autoencoder is another way to differentiate or to group different things together. Why this is helpful in healthcare? Now, let me bring you another use case that may not be directly related to the surgery or clinical setting, but administratively. If we apply AI correctly, AI can also detect which healthcare claims is legitimate and which one is fraudulent or flagged as fraud, waste, and abuse. That really will help us not only from a clinical level, but it's in an administrative level. And that's how AI being an assistant for us. Not only like if AI is good as our assistant, what's better than one assistant is definitely two assistants, right? So again, another movie here. Catch Me If You Can, my very famous movie. It talks about Leonardo DiCaprio produce fake check, and then Tom Hanks, he acts as an FBI agent to detect this kind of fake checks and see which one is doing better. So this very approach, like assistant times two, is called generative adversarial network. It's used two AI network to compete with each other, and the result will be both AI network will become better and better. And in healthcare, we can actually apply this. The one who create or produce the fake check is called generator. We can use generator, keep generating like new molecule for drug discovery. And then on the other hand, we have a discriminator, the Tom Hanks, to look at this drug and see whether this drug is legitimate or not. Does it make sense or not? So by applying this AI in this game network, we can improve healthcare in this manner in a lot better and faster way. So at this point, I know I ask you a lot of questions, but I know some of you may have this one question in your mind. So what? So Cupid, good for you that you explain all this kind of AI terminology and all the history. By the way, your hand drawing is a little bit ugly, but so what? What really does it impact me as the one attending this section? Let me tell you, or let me remind you this. What is the title of this course we are taking now? It's AI Catalyst for Global Health. I like this topic because it highlights a very important point and role about AI. Catalyst. What is a catalyst? A catalyst is something when you add it in a process, it will escalate or accelerate the process from start to finish much faster. And you don't need a lot, but you need to apply the right catalyst to the right process. If you think about this in healthcare context about AI, it is the same. Before you even apply AI, you need to know what is your process. If you don't even know what is your process, having AI will not help. But if you know what is the process, if you know which AI is helpful for this process, you do not need a lot of AI. You just need a little tiny AI in the right process, right AI catalyst in the right process that will accelerate your healthcare process. And I'm not sure whether you're aware of that, but I am a fan of high tech. And when we are talking about high tech, Tesla and Uber, those are the very famous high tech companies. Let me ask you this. What's the common between these two companies? I know there is no sound, and I don't expect you to know immediately, but in my mind, both Tesla and Uber, they are in the car industry. However, they tackle car in a very different way. Tesla, it revolutionized how the car should work from a gasoline oil engine to a motor, electric motor. It creates a brand new technology for the car industry. However, on the other hand, Uber does not really create or invent something cool. Like it used mobile app, map, GPS. It's not something like very revolutionary, but it puts it in a very new way to connect the driver with the passenger, to the passenger. It forms a new business model of how the car industry should work. Which one is right? Which one is better? That leads me to the very first question that my son asked me. So, teacher can't tell, that means AI. Remember, at that time, there was no ChatGPT, at least not as popular. Maybe there is ChatGPT in the lab. So my mind at that time, few years back, I would say, okay, so if you can really use AI so that your teacher cannot tell, no matter what, you are a cool kid, you are a smart kid. But fast forward a few years later, today, using ChatGPT to do your homework is the norm. You just need to admit this. But the problem is you need to know that some people just use the AI as is without critical thinking. So as you rely on this without doing any critical thinking, then you will be replaced. So a lot of people are wondering or worried when AI, this kind of very powerful technology, comes into the market. The question they would ask is, well, that means I will lose my job. Is that right? Yes, you lost your job. But this kind of question, if you think many years ago, when a car is invented, what happened? When a car was invented, some jockey was worried about my job will be replaced, which is actually true. Because when you look at nowadays, there is no jockey around, but there are a lot more drivers than jockey and than we had before. Why? Because those who lost the job is the one who really don't adopt this new technology. And who knows how to use this technology and adopt this and use this with the critical thinking is the group that will still survive and thrive. So whether Tesla or Uber, if you really have the passion to create a new technology, new CNN, new RNN, new GAN, go ahead and build your new AI model. However, if you do not have that passion, if you not feel like you build a new engine, you can also be an Uber to leverage what other people has already built in the AI industry and use it to help in healthcare. I guess we are closing to the end, and I know that at least one question that someone may ask. Hey, Cupid, good for you. I appreciate you tell me this story and explain all this kind of AI technology and how is it going to apply to healthcare. Good for you. But I still do not believe. You explain AI to your kids just like what you said. You're lying. Can you please tell me whether it's true or not? Instead of me telling you whether the story is true or not, so let him to tell you. Tell me what is AI.
Artificial intelligence.
What is it exactly?
Artificial, it's supervised learning, unsupervised learning, and reinforcement learning.
What exactly is supervised, unsupervised, and reinforcement learning?
Supervised learning is when you bring something to the computer and the computer remembers it. Unsupervised learning is when you tell the computer to do something and you don't tell him instructions. Reinforcement learning is when the computer does something right and you give him a point, and when the computer does something wrong and you take away a point.
Yeah, good job. So it is real. It is not only I lie to you and come up with this story to tell you what is AI in this Introduction to AI in healthcare. It's really happened. In fact, I convert this conversation into a presentation in an AI in action meetup. We have 1,500 people in the meetup. So after I present to the meetup, my colleagues, Professor Gao, he told me, he said, hey, Cupid, the way you explain AI to kids, it's actually very helpful also for professional, for manager, or for the leadership. So I convert that meetup presentation to a keynote, which I present in different places, including like different cities in the world, Singapore, Shanghai. And then last year, I find out that it's not very efficient that I need to be there to talk every time someone wants to know about that, let's say in this scenario. So I convert and include all my lecture notes from the class that I taught in University of Maryland to become this book. So this book has all of the material that I share with you today. In fact, I pulled the material from this book to share with you this morning or this today. And I talked to the publisher and we made the decision in this weekend until Monday, we reduced the price 80% to help out in this course. We hope that by doing this, more people can find AI be more accessible. So use this link, use the QR code, and use this link to order the book, the electronic copy. For this weekend until Monday, you will get this special discount. And I hope this is helpful for you as a gift to you. And at the same time, besides the book, I am also on LinkedIn. So please follow and connect with me in LinkedIn. From time to time, I will give more tips, not only in AI, but technology in general. So I really hope we can connect in LinkedIn. So one more channel that we can communicate. And remember, I asked you a question throughout this whole section that when will I be in Boston next time? In fact, I will be in Boston September for the Global Health Summit. And I really hope that I can see you at that time in person. So my very, very last question to you. Oh, by the way, I just want to make sure you understand this. This is only the first of the 10 section series about the AI catalyst for global health. So now you know all this introduction that I told you. And in the next 9 sections, you will learn a lot more from the industry's experts. How do they really apply AI in healthcare? So please use this time to polish your knife to really think about how AI can be applied in healthcare by attending all these sections. And my very last question to you, I promise, is this. So what do you want me to talk about in Boston in September? I really need your feedback so that I can tailor this kind of session so that it will be beneficial and provide value to all the audience there. With that being said, thank you very much. And then I think I can now turn my sharing off and my camera on so that I can see you in Zoom. Hey, can you guys hear me?
Yes, we can.
All right. Okay. So I think we are right on time, or maybe 2 minutes later. I'm sorry about the delay. And let me know if there is any pressing question before we adjourn.
I got one.
Hey Cupid, that was a great talk. So we do have one question regarding the average number of training hours that could lead to an AI or algorithm overfitting.
Very good question. And unfortunately, I cannot tell you. And it really depends on the data, the amount of data, and the pattern of the data. Some data, if the data set itself has already got a very clear pattern, then you may just need a few training section, and then you'll be getting a very saturated model. But some of the data are very complicated. They have a lot of different dimensions. In that case, you will train a lot more. So instead of telling you how many epoch that we need to perform, I would actually rather to tell you to monitor the accuracy when you train. As long as you train, you can actually keep track of the accuracy as the model improved. So I would say maybe around 80% or so, stop right there and try to float it to another set of data that the model hasn't seen it before. In that case, then you can compare the result of the performance based on the training set versus the validation and see whether the model is too overfit or still underfit.
Great. One other question. Someone is asking, what are other types of machine learning outside of deep learning?
So I think I said one like decision tree. So if you remember right here, AI is the general concept of how to make a computer mimic the human intelligence. Machine learning is like I don't need to provide like an explicit instruction, but the machine learn itself. Decision tree is one, Monte Carlos, and near K, like a nearest K. So there are a lot of different, I would call it shallow learning. And in fact, not sure it is a commercial time or not, but in this book, there is actually a chapter to talk about the top 10 AI algorithm family. And those algorithm, it's not deep neural network. It's the shallow learning that I think you will find it very useful. So take advantage of this promotion or this special over this weekend. There is a chapter right there to explain a lot more about this top 10 algorithm. All right. So any more questions before we adjourn? I really hope you enjoy this. Sorry.
Sorry, one more question that just came up. So how can someone create a model locally? What hardware would they need? Would they need to buy a GPU? Basically, what are the hardware requirements?
So what's the size of the data set?
They did not specify, but I guess
Okay.
we could speak just generally.
So if you just want to test out, different algorithm in the model, you don't need a GPU. You just need to download TensorFlow or PyTorch. You just start program. If your data set is like maybe few 100 MB, a regular computer should be able to handle it without any problem. But if you are moving to an organizational or enterprise level, which you have few gigabyte of data, and then you need to build a very deep neural network, then starting from there, I recommend you should not buy a GPU. You should do it on the cloud because like a GPU is expensive and you do not know whether this is like really effective or not. So if you put it on the cloud, AWS, GCP, or Azure, then you can really train it right there on demand. So you don't need to incur the cost of purchasing the hardware. That's my recommendation. All right, so I know that there are some forms listed in the chat. I believe those are part of the like a feedback form. So please help me, at least help me with something here by going there, fill the form, and if you really purchase the book, I hope you that if you feel the book is either good or bad, leave your comments at Amazon so that it will help other readers to make their next purchasing like a decision. So those are the two things. I hope you can help fill the form, feedback form, so that I know how can I improve my presentation next time. And if you really get the book, I hope you can also help by providing your honest opinion about the book, good or bad, in the Amazon, so that it helps not only me but also the other readers when they got the book, should they get the book or not. So that's basically my simple ask, and I hope you enjoy the section today. If there is no more question, then I think we can call the adjourn, right?
Yes, thank you so much, Cupid, for an amazing lecture. The feedback is looking amazing. Everybody is loving it, saying thank you so much. And thank you so much for everybody for coming in for the first lecture of this course. Like we said in the chat, please make sure to fill out. There's only one form. Please make sure to fill this out for attendance. And that will make you eligible to receive this certification at the end of this course. And I know we've been getting some questions about where to find these resources and the recordings. The recording of this lecture and all future lectures will be on the website, as well as a follow-up email after the lecture. And I will also resend the syllabus that has all of the dates of the lectures, and the pre-readings will come a week before each lecture. Thank you so much, everybody.
All right. Thank you very much. Hope to see you September 19 to 21st in Boston. If not, see you next time.